first question is the following. A, B, C, D are distinct positive numbers. Distinct positive numbers in HP. Distinct positive numbers in HP. Which of the following are true? Which are true among the following? The first one is root of A plus D by B plus C plus root of B plus C by A plus D is equal to root of AD by BC plus root of BC by AD. The second one is ABC plus BCD is equal to ABD plus ACD. The third one is 1 by A plus 1 by C is equal to 1 by B plus 1 by B. The fourth one is 1 by A plus 1 into 1 by D plus 1 is equal to 1 by B plus 1 into 1 by C plus 1. This is a more than one choice question. So when you come across a question like this, A, B, C, D are distinct positive numbers which are in HP. Which of the following are true is the question. See, usually my suggestion is, whenever you come across questions like this, don't try to do them in general. It takes a lot of time if you do like that. So the best way is, see, this must be true, whatever may be ABCDs which are in HP. So therefore, you select 1 by 2, 1 by 3, 1 by 4 as ABCD. Yes, it must be true for all. See, here ABCD are distinct positive numbers which are in HP means ABCD may be anything. All this must be what? True. If at all this is true, this must be true for this also. So now you take one simple HP like this. See then, if you take reciprocals 1, 2, 3, 4 are in what? A. So this is your A. So A is equal to 1, B is 1 by 2, C is 1 by 3, D is 1 by 4 you choose. Substitute in LHS. Substitute in RHS, see whether they are equal or not. If they are equal, then this is correct. Substitute here, see that LHS is RHS. Here also same thing. So I will verify, you can verify this, you can verify this, you can verify this, you can verify this. I will verify just 2 or 3. Shall I verify this? What is ABC will get? 1 into 1 by 2 into 1 by 3 means what? 1 by 6. 1 by 2, 1 by 3, 1 by 4. So 1 by 24. What about this? 1 into 1 by 2 into 1 by 4 into 1 by 8. 1 into 1 by 3 into 1 by 4 means what? 1 by 2. What is LHS? LCM is 24. 6 fours 1. 5 by 24. What is LCM here? 24. 8 threes 2. 5 by 24. So this is correct. Similarly verify this. What is 1 by A? 1 by A is 1. 1 by C is what? 3. Correct. So 4. What is 1 by B? 2. 1 by D is what? 2. So this is also correct. Yes. What about this? 1 by A is 1. 1 plus 1 is what? 2. 4 plus 1 is what? 5. So this is 10. What is 1 by B? 2. 2 plus 1 is 3. Into 4, 12. So 10, 12. So this is wrong. So this is correct. This is correct. Similarly, verify this, you will get this is also correct. So your answer is 1, 2, 3 like that. This is how you have to solve this type of questions in order to save the time. See, we can do in general also. We can do in general also by going for the condition when A, B, C, D are in HP, 1 by A, 1 by B, 1 by C, 1 by D are in AP. For example, this 1 by A plus C. This plus this is equal to this plus this. Like that, we can write and do it. Yes, okay, understood. So, but I don't advise you to do in general. Take some numericals, check out the results. This is the best way to tackle this problem. Okay, right. Say, the next question is 1 plus 2 plus 3, 3 plus 5 plus up to A plus 1 plus 3 plus 5 plus up to B is equal to 1 plus 3 plus 5 plus up to C. Up to C. Where each contains the sum of the consecutive odd integers. Each contains sum of the consecutive odd integers. Then smallest value of A plus B plus C is equal to how much? Smallest value of A plus B plus C is equal to how much? That is the question. See, listen. If you observe closely, 1 plus 3 plus 5, let us say up to n terms. Up to n terms. To n minus 1. Right? A plus n minus 1 into 2, if you write 1 plus n minus 1 into 2 means 2n minus 1. This is nothing but n by 2 into first term plus last term. First term plus last term means you are going to get n square. So 1 plus 3 plus 5 up to n terms happens to be n square. Right? Now, this is a perfect square. This is a perfect square. This is also a perfect square because there are some sums of what? Consecutive odd integers. So this is n square form, this is some k square form, this is some p square form. Right? See, sum of two squares is equal to sum of two squares is equal to a perfect square. And of course, those numbers are what? Integers means they must be Pythagorean numbers, Pythagoras numbers, right? So the minimum Pythagoras numbers with integers you can select like this: 3 square plus 4 square is equal to 5 square. Correct? So here you should get how many values? 3 values. Means 1 plus 3 plus 5. Correct? Here how many values? 4 values. 1 plus 3 plus 5 plus 4. Here how many values? 5 values. 1 plus 2 plus 3 plus, 1 plus, not 4, 7. 1 plus 3 plus 5 plus 7 plus 9. So this will be 9, this will be 16, this will be how much? 25. So the minimum means what? This is the minimum we can have. So A is equal to 5, A is equal to 3, only 3 terms, number of terms. A is equal to 3, B is equal to how much? 7, B is equal to 4 terms. And terms? 5 terms. So what is A plus B plus C? You can have it is understood that A terms. This A terms and right. Makes sense. This B terms. This C terms. So A terms, B terms, C terms means A must be 3, B must be 4 and C must be 5. So A plus B plus C minimum value is how much for you? 12. So you can complete the problem like this. Right? So this is one of the interesting questions. See, by this time you should know that sum of consecutive odd positive integers, sum of n first n consecutive odd positive integers is equal to n square. If by seeing this problem, if that point is there in your memory, you can easily solve this problem. Understood? Right. Okay. The next question is an is equal to square root of 1 plus 1 minus 1 by n whole square. 1 plus 1 minus 1 by n whole square plus square root of 1 plus 1 plus 1 by n whole square. Right? N is greater than or equal to 1. N is of course greater than or equal to 1. Then the value of sigma I is equal to 1 to 20 1 by ai. Sigma I is equal to 1 to 20 1 by ai is equal to how much? Sigma I is equal to 1 to 20 1 by ai. Clear? First, you simplify this. Square root of, you take LCM, n square plus n minus 1 whole square by n plus square root of n square plus n plus 1 whole square by n. What is 1 by an? You can take LCM, you will get n by square root of n square plus n minus 1 whole square plus square root of n square plus n plus 1 whole square unit. I should have written this first, next this, right? Okay, right. Now you rationalize. When you rationalize n into this square root of n square plus n plus 1 whole square, square root of n square plus n minus 1 whole square by n square plus n plus 1 whole square minus n square minus n minus 1 whole square. These two will go. See, a plus b whole square minus a minus b whole square is what? 2ab. Means, 4ab. So you are going to get what? 4n. n square plus 2n plus 1 minus n square plus 2n. So 4n you will get here. n by 4n is how much? 1 by 4 into square root of n square plus n plus 1 whole square minus square root of n square plus n minus 1 whole square. That is your 1 by n. Right? So 1 by n value we got like this. After getting 1 by n value like this, then the rest of the problem, I think we can easily guess what I am going to do. Is nothing but what? Telescopic cancellation. I is equal to 1 to 20 ai. Instead of n you write I. 1 by 4 I will keep here. Square root of I square plus I plus 1 whole square square root of I square plus I minus 1 whole square. 1 by 4 into, you put I is equal to 1. This is 1. This is what 1 plus 1, 24 into root 5 minus root of 1. Right. Plus I is equal to 2 means 4 plus 9 root 13. Any 4 plus 1 root 1. Next I is equal to 3. 9 plus 16 root 21 minus square root of 9 plus 4 30 etc. Finally 20. The root of 20 square plus 21 square minus square root of 20 square plus 19 square. This is for n is equal to 1. This is for n is equal to 2. This is for n is equal to 3. N is equal to 3 like this and so on. See, if you consider up to this will cancel. You will get this minus this up to 2 terms. Up to 3 terms means this will cancel, this minus this will cancel. Up to this when you do, this will cancel with the other one. You will be left with what? Left with this is root of 20 square plus 21 whole square minus 1 you will get. 20 square is what? 400. 21 square is how much? 21. 21 means 1, 3, 2, sorry. 2 fours, 441. So 400, okay, 441, 1, 4, 8, 841. What is 841 approximately? 841 and 29, sure, square root of this is 29. So 29 into 29. 26. Are 18, 26, 4. Okay. So you will get 1 by 4 into 29 plus 1. So 28 by 4, which is 7. This is how you have to think. Yes. Okay. Right. So the next question is, x greater than 0, x, comma step x, comma fractional part of x are in GP. Then find the value of x. X, step x, fractional part of x are in GP. What is the value of x? X is positive. All of you know fractional part of x is equal to x minus step x. So you are having x, step x, x minus step x are in GP. Therefore this square is equal to this into this. So step x whole square is equal to x into x minus step x. So you are going to get x square minus x into step x minus step x whole square is equal to 0. You will get like this. You divide with step x whole square throughout. You will get x by step x whole square minus x by step x minus 1 is equal to 0. So you got a quadratic in x by step x. You got quadratic in x by step x. You solve this. X by step x is equal to 1 plus or minus square root of 1 plus 4 by 2. You have to choose 1 plus root 5 by 2 only, because x is positive, step x is also positive. You have to choose only root 5 plus 1 by 2. So what is x now? Root 5 plus 1 by 2 into step x. So this is the relation you are going to get. Yes, I think you are following. It's very simple. Fractional part is x minus step x. You all of you know this. So you will get a quadratic in what? X by step x. You will get an equation. You will get a relation between x and step x like this. Now, listen. What are the values step x is capable of taking is our question. Step x is equal to 0. Yes. X is greater than 0. Right? Step x is 0 means what? X is 0 you will get. But x cannot be 0. X is what? Greater than 0. So step x 0 is ruled out. Step x is equal to 1 I consider. Then I will get x is equal to how much? Root 5 plus 1 by 2. See, when does step x is 1? X value lies between 1 and 2. Is root 5 plus 1 by 2 is lying between 1 and 2? Yes. Root 5 is approximately 2.3. This 2.3 you consider. 2.5 also, even if you consider, there is nothing wrong, because you will get 3.5 by 2 less than 2 only. So no problem. So this is valid. Step x is equal to 2. X is equal to how much you will get? Root 5 plus 1. Root 5 plus 1 means here our x value should lie between what? 2 and 3. Root 5 plus 1 is what? More than 3. So this is ruled out. This is ruled out. Step x is equal to 3. X is equal to root 5 plus 1 by 2 into 3. See, step x is 3 means x value should lie between what? 3 and 4. But this value is how much? More than 4. This value will be more than 4 because approximately 2.3 you can 2.2 you consider, okay. Then you are going to get how much? 3.2 by 2 to 1.6. 1.6 into 3 is what? 4.8. So more than 4. So this is also ruled out. So all other values, if you substitute, they are all ruled out. Finally, you will be left with what? X is equal to root 5 plus 1 by 2. So this is the only solution. So x greater than 0, x, step x and the fractional part of x are in GP means the possible value of x is what? Root 5 plus 1 by 2. Okay, understood? Right? Okay. See, the next question is sigma k is equal to 1 to infinity 1 by k plus 2 into root k plus k into root of k plus 2 is equal to root a plus root b by root c. Then what is the value of a plus b plus c, where a plus b plus c are integers? This is our next question. You first take up this, rationalize this. If you rationalize, you are going to get k plus 2 into root k minus k into root k plus 2 by this square minus this square. Means k into k plus 2 whole square minus k square into k plus 2 units. So this is as good as you try to simplify this. Shall I simplify this separately? I will simplify like this. K into k plus 2 is common. So k plus 2 minus k will get. So finally this. So this is k plus 2 into root k minus k into root k plus 2 by 2k you will get. 2k into k plus 2. Okay, understood? I am picking up this, rationalizing and not like this. You keep 1 by 2 outside. This by this. K plus 2 will cancel. Root k by k is how much? 1 by root k. This by this. Minus 1 by root of k plus 2. Just rationalization. When you rationalize, you got like this. Yes, these are all straight steps. I hope you can easily follow this. Just rationalize. You are going to get 1 by 2 into 1 by root k minus 1 by root of k plus 2 like this. Okay, understood? Now, you replace this with this. Sigma k is equal to 1 to infinity, 1 by 2 you take outside, 1 by root k minus 1 by root k plus 2. You range your k values. 1 minus 1 by 3. 1 by root 2 minus 1 by root 4. K1, K2. K3, 1 by root 3 minus 1 by root 5. K3. Plus K4, 1 by root 4 minus 1 by root 6. You go on writing like that. 1 by root 3, 1 by root 3. 1 by root 4, 1 by root 4. Next you are going to get 1 by root 5 minus 1 by root 7. This. You see, as if you go on writing like that, all terms will vanish. See, when all terms will vanish, what are the remaining terms for you in this series? Only these two. So 1 by 2 into 1 plus 1 by root 2, you will get like this. Okay, understood? All will cancel like this, all will cancel except these two terms. So this is 1 by 2 into root 2 plus 1 by root 2 you got. This is root 2, this is root 1, send 2 inside it. Root 8 you will get, correct? This is root 8. So A is 2, B is 1, C is 8. Hence you can estimate what is A plus B plus C. Very simple. A simple mains question like this. Right? Okay. Our next question is limit n tending to infinity sigma r is equal to 1 to n r plus 2 by r into r plus 1 into 2 to the power of r plus 1. Limit n tending to infinity sigma r is equal to 1 to n r plus 2 by r into r plus 1 into 2 power r plus 1. See, whenever you come across a problem like this, you should always think about what a telescopic cancellation, because 2 power r plus 1 or r plus 1 are there. You should plan something for what? Telescopic cancellation. You see how I am planning. This is sigma r is equal to 1 to n. Shall I put like this? 2 into r plus 1 minus r by r into r plus 1 into 2 power r plus 1. See, this idea how I got it. My idea is I want to first cancel r plus 1. Next I want to cancel what? R. That is the idea. So for that sake I adjusted r plus 2 in the form of what? 2 into r plus 1 minus r like this. So when you split it into two fractions, this by this will give you how much? This by this will give you 1 by r into 2 power r. Correct? 2 power r plus 1 means 2 power r plus 1 will minus 1 by this will give you r plus 1 2 power r plus 1. Of course, limit, finally we will apply limit. Okay, limit n tending to infinity, right? Limit n tending to infinity, right? If you write this, next the problem straight away follows telescopic cancellation. You range your r values. Limit n tending to infinity. 1 by 1 into 2 minus 1 by 2 into 2 square plus 1 by 2 into 2 square minus 1 by 3 into 2 cube plus 1 by 3 into 2 cube, 4 into 2 power 4, etc., etc. These two will cancel. These two will cancel. Like that, all will cancel. As n tends to infinity, all those things will vanish. You will be left with what? 1 by 2. Okay? Followed? This is what you are supposed to do it. Just the telescopic cancellation. See, sometimes, since I'm experienced with this idea clicks, you can just do the guesswork. I want to get what? R 2 power R. R plus 1 2 power R plus 1. Then how to plan? That we have to think. See, when you do more and more problems like this, yourself will get the idea. See, mathematics comes through practice and your involvement. See, to solve a good advanced paper, you need not be a genius. You require what? Good practice, good exposure to many problems. See, in the advanced, what happens is, most of the problems, at least if the paper is very tough, definitely you can take it granted that 50% of the paper will be known models only. In the 50% of the paper, even if you do to 30%, you will get a very good rank as far as maths is concerned, if the paper is tough. Right? See, some extraordinary people will be there, for them some extraordinary ideas you will get. That you leave it. That is meant for what? Top 10. That you leave it. But in general, to get a very good rank below 500 or below 1000, your duty is what? Practice and practice. Practice, involve, try to remember, go on practice. See, the next question is, sigma I is equal to 1 to infinity, sigma j is equal to 1 to infinity, I power 3i into j power 3j is our next question. See, this sigma is meant for variation of j, this sigma is meant for variation of I. If something is independent of j, it can be taken outside. So this is as good as I is equal to 1 to infinity I power 3i. j is equal to 1 to infinity j power 3j, you can write like this. Or we can evaluate separately this. So now consider sigma j is equal to 1 to infinity j by 3 power j. So you will get 1 by 3, 2 by 3 square, 3 by 3 cube up to infinity. You will get the AGB of infinite number of terms. You better take out 1 by 3 outside, 1 plus 2 into 1 by 3, 3 into 1 by 3 square up to infinity. So this is just like a plus b into r, a plus 2d into r square, etc. So 1 by 3 into a by 1 minus r plus d 2 minus 1 r 1 by 3 by 1 minus 3 whole square. If you simplify further, you are going to get 1 by 3 into this is 2 by, this is nothing but 3 by 2. That is how much? 1 by 3 by 4 by 9. 3 by 4. So this is 1 by 3 into how much? 3 by 4. So 3 by 4. So this is all how much for you? 3 by 4. So this is 3 by 4. This is also 3 by 4 because instead of ranging j, you are ranging I. So your final answer is how much for this? This is 3 by 4 into 3 by 4, which is 9 by 16. Yes, understood? So the answer is 9 by 16. It is a simple AGB problem. The next question is sigma j is equal to 1 to infinity. Sigma I is equal to 1 to infinity. J square I by 3 power j into j into 3 power I. J into 3 power I plus I into 3 power j. This is our next question. Sigma I is equal to 1 to infinity, sigma j is equal to 1 to infinity, sigma I is equal to 1 to infinity, this. See, this is a peculiar idea problem. Listen, you can call this as yes. See, if we closely look at this problem is as good as j is equal to 1 to infinity, I is equal to 1 to infinity. You divide above and below with, let us say, j square I. Then you are going to get like this. You divide above and below with what? This is j. Divide and above and below with j square I 3 power. When you send this j, you will get what? J like this, correct? So you are going to get ji by this. See, one j, you bring it down. Now you divide with ji. 1 by 3 power j by j. When you divide with ji, you will get 3 power I by I plus 3 power j by j you will get, correct? First j square is there, divide with j, you will get like this. Then divide with what? Ij, you will will get like this. Okay, understood? After dividing like this, now listen, after all I and j are what? Independently varying. Suppose even if I interchange I and j here, it makes no difference. So this is S. S is also sigma j is equal to 1 to infinity, sigma I is equal to 1 to infinity, 1 by 3 power I by I into 3 power j by j plus 3 power I by I. So what I mean to say is, as far as this summation is concerned, I and j are what? Independently ranging. So they are interchangeable. It makes no difference. Right? It makes no difference if you interchange what? I and j. Yes, I think you follow this. So I and j can be interchangeable. Understood? Right? Now you just observe this. See, if you observe this problem, S is what? This. S is equivalent to this. S is also equivalent to this. You consider 2S, right? So listen, you just observe these points. For me, 3 power I by I is just like A, then small a. This is B. It is in the form of 1 by B into A plus B. B into A plus B. This is in the form of what? 1 by B M by A into A plus B. So when you take LCM, AB into A plus B will get. Here what? A plus B. So this is precisely what? 1 by AB. Yes, understood? I think you are following the problem. So, when you add these two things, what you are going to get? Sigma I is equal to 1 to infinity. I and j interchangeable, makes no difference. So, this plus this will give you 1 by AB. AB means what? 3 power I by I, 3 power j by j. Correct? 1 by AB is nothing but 3 power I by I, 3 power j by j. This is as good as I is equal to 1 to infinity, j is equal to 1 to infinity, I by 3 power I, j by 3 power j. Correct? Okay, for I by 3 power I, j by 3 power j, you are going to get. Just now you have seen this problem. I is equal to 1 to infinity, I by 3 power I, j is equal to 1 to infinity, j by 3 power j. Just now you have seen this problem is equal to 9 by 16. Just now you have seen the earlier problem. So S will be equivalent to 9 by 32. S will be equivalent to 9 by 32 you are going to get. So this is of course a very good problem, very important for any examination point of view. Yes, I think you followed this, right? The next question is 1 by factorial 3 plus 5 by factorial 4 plus 11 by factorial 5 plus 19 by factorial 6, etc., etc., up to n terms. Up to n terms. Then find the value of, let us say this is Sn. Find the value of Tn and also S infinity. And also S infinity. This is where next question. Right? So listen, this is a very good question. See here, you should observe that 1, 5, 11, 19, they are all in what? They are all in 7, 7, 6, 9. They are all in what? They are neither forming AP nor forming a GP. So first, I will try to calculate nth term of numerator. So this is 1, 5, 11, 19, etc. Let us say Tn. You forget about this. Tn of numerator. S is equal to, you push one term ahead. 1 plus 5 plus 11 Tn like this. Subtract 1 plus 4 plus 6, 11 minus 5, 19 minus 11 is what? 8, etc. minus Tn. You forget about 1. 4, 6, 8, etc. they form arithmetic progression. I already taught this type of model, so forget 1. Remaining all will form what? AP. So listen, up to this n terms, these are how many terms up to this? N minus 1 terms. Bring Tn to here. 1 plus n minus 1 by 2 into 2a plus n minus 2 into d. Understood? So this is 1 plus n minus 1 into 2, you can cancel. You will get what? Finally n plus 2 na? 4 plus n minus 2, which is nothing but 1 plus n square plus n minus 2. So this is n square plus n minus 1. N square plus n minus 1 you are going to get. Okay, understood? So nth term of the numerator happens to be n square plus n minus 1. Understood? That is nth term of the numerator. Now, after knowing nth term of the numerator, what is your Tn here? Tn will be n square plus n minus 1 by factorial n plus 2. Correct? Because it starts with what? 3. Here n is equal to 1. So you should put what? N plus 2. Now we check it up. N is equal to 1 means 1 by factorial. N is equal to 2 means 4 plus 2 minus. You will get like this. This is your Tn. So nth term of the series, you got it like this. This is your nth term of the series. After getting nth term of the series, Sn is equal to what? Sigma Tn. Sigma n square plus n minus 1 by factorial n plus 2. N value ranges 1 to n. Okay, n value ranges 1 to n. Now, the main hurdle hurdle is here. How to adjust this to get to telescopic cancellation form is the main hurdle. For that, you watch this manipulation. N square plus 2n you put minus of n plus 1. Okay, na? By factorial n plus 2. So this 2n minus n minus 1. You write this by this, which is n into n plus 2 by factorial n plus 2 minus n plus 1 by factorial n plus 2. This is as good as n by factorial n plus 1 minus, this can be written as n plus 2 minus 1 by factorial n plus 2. This. This is also, you put it n plus 1 minus 1. Then finally you are going to get this by this is 1 by factorial n minus 1 by factorial n plus 1, one set, minus of this by this is what? 1 by factorial n plus 1 minus 1 by factorial n plus 2. So this is a peculiar manipulation. You see what? N square plus n minus 1, I am first putting it like this. This by this. This by this. This n plus 2 factorial n plus 2 means n by factorial n plus 1 will get first, adding 1 and subtracting 1. This is n plus 2 minus 1, you write. This by this is this. This by this is this. This by this is this. Yes, okay, follow? So, finally, what you are going to get? Sn is equal to sigma n is equal to 1 to n. 1 by factorial n minus 1 by factorial n plus 1, one set. Minus, shall I split it? Sigma n is equal to 1 to n. 1 by factorial n plus 1 minus 1 by factorial n plus 2, other set. So this is one telescopic cancellation, here one more telescopic cancellation like this. That's how I am planning it. So that's why this is a very peculiar and very important question. Now when you range your n values, you will get how much? 1 by factorial 1 minus 1 by factorial. 1 by factorial 2 minus 1 by factorial 3, etc. Minus 1 by factorial 2 minus 1 by factorial 1 by factorial 3 minus 1 by factorial 4, etc. These two will cancel, these two will cancel, cancellations will take place like this. Here will be, if you go up to infinity, you will be left with 1 here. If you go up to infinity, you will be left with what? 1 by 2 there. So yes, infinity you want, which is how much for you? 1 by 2. This is how you have to think. This is of course a very peculiar problem. I think we are all following this.